All right. Good morning. I guess it's noon. So, good afternoon. Oh, I should have done this before I went live. It's really dark and stormy today. And it's made the light in here really weird, so I feel like I look really dark. It's kind of weird. All right, so here's what we're doing today. I've been wanting to do this for a while, and I've been planning this for a while, and I just procrastinated the crap out of it during this whole coronavirus thing. But now that I feel like I'm a little more organized. So I was recently made an AWS Educational Ambassador. And basically what that means is I get access to a lot of cool tools and stuff to help people learn the AWS or Amazon Web Services platform. And so one of the things that I wanted to do, not only for my own students, but for anyone else who wanted to learn along, was to kind of work on some of the notes and study materials and things for the Certified Cloud Practitioner Exam. And so here's the information about the exam. This is the lowest level of AWS certification. Kind of goes over some of the foundational aspects of what is cloud computing, specifically understanding the AWS platform and things like that. So this is going to take some time, and I'm going to do this over the course of several days. But I would hope that would help you prep if you are thinking about learning more about AWS in general, but also maybe going for that Cloud Practitioner Exam. And then personally, this is going to help me kind of have a foundation of learning, because I've learned this and I've done this and then I forgot it. Of then going for the next level certification, and then I'm going to do the same thing to prep for that. And so my goal personally would be to sit that exam, which would be the Certified Solutions Architect, that associate level one, or maybe the developer one. I haven't quite decided, but I am leaning more towards the Solutions Architect one by the end of the summer. Considering that I'm not going to be traveling this summer like I usually do, and work is going to be fairly quiet, I think, and we're not going to have a lot of summer classes at the college. I'm really feeling that that's probably a valid goal. If I feel like I can't hit that goal, or maybe I sit the exam in August and I'm not successful, then that would give me some additional time to maybe then try again before the end of the year. But that's just it's a personal goal. It's not something I need for work or for my career or anything, but it's simply because I really think, at this point, so much lives in the cloud, and it's such an important skill set to have. And I know when I talk with employers about what students need as entry-level software developers, like what are some of the key things that they really should be graduating with, understanding these platforms, these tools, how to use them, how they integrate in with maybe traditional on-premise systems, things like that. How does that work? Then that's super important. And you may not be an expert at it, and it takes several years of understanding these tools and stuff sometimes to become an expert at it. But at least knowing those basics and those fundamentals and having some knowledge to grow on, that's what they're looking for. And so, like I said, this is going to be kind of a multi-part thing that I'm going to be working on. And so what I'm going to be doing today is kind of some setup of my notes and on how I'm going to organize this. And so one of the things that I have, oops, and I meant to put this in the stream title, is oh, where's my bot? Aww, where's my bot? This is what happens. You don't stream in a while and it's like your bot goes on strike. All right, hold on. Let me get the bot back up. Okay. Where is he? I don't see that the bot is in the chat. Let me turn him off. Oh, good Lord. Okay. Okay, well. I turned him off and turned him back on. Let me see if I can get him to join the chat. Rude. Rude bot. All right. Well, if that doesn't work, then I just had a command for this file right here. So I'm going to be organizing all of my study notes into a public GitHub repo document. And I'm doing this just because it's a little easier to share this kind of thing than putting it in like a Google Doc or something like that. So you can follow along with these notes. I've already got a couple of links and things in there. Pluralsight is a paid thing, but I'm got some other resources and things and stuff I'm gonna put in here. And yeah, so that can help you kind of focus what you're gonna be doing. But the main AWS Cloud Practitioner site has some good information. Let me get this exam guide. There's also sample questions. Let's pull this up so we can look at this. But this talks about what you need to learn or understand in order to sit this exam. And so basics of kind of like the AWS cloud, that global infrastructure, what is that? What does it mean? Some of those architectural principles, the AWS cloud value proposition, which has to do with like competitiveness and pricing, and there's things like that on the exam. Key services, so going over kind of all of those different key services and what does that look like. You know, and they give the example there, compute and analytics. Going over basic security. Now there's a lot that goes into security, and in fact there's even like a security specialization if you're interested in that. But basic security and compliance at a very, very low level. Billing, account management, pricing models, stuff like that is important. Yeah, so. And then documentation and technical assistance, like where do you find that information? How do you get it? Stuff like that. And then some of the core characteristics. Now I'm focusing primarily on AWS, one, because I'm a cloud ambassador, but you know, you should just note that there's like the whole Microsoft Azure platform too. And I could probably show you a few things. I don't have nearly as many tools for Azure as I do for AWS, but we could definitely dig into some differences. So that you understand kind of what that's about. And sorry, I kind of seem like I'm all over the place with my screens today. I'm monitoring a bunch of other things, so forgive me if suddenly I just like trail off. But all right. So here are the documents. Ooh, that's tiny. That they give you. This is just what we just looked at. Recommended knowledge, 6 months of experience with the cloud in any role. 6 months is good. If you've learned on your own, you know, you might be able to do this faster. I think that, and like once students, if they take an actual class with me where it's meeting like twice a week and they're doing reading and they're doing labs and they're doing work and things like that, then 4 months, you know, a traditional 16-week semester is a reasonable amount of time before you can take this exam. So a basic understanding of IT services and the AWS cloud platform. And so here's where it gets into like what's actually on the exam. And that's important to help you prepare when you're doing these kinds of exams as well. So with a lot of these types of certification exams, you have these distractors. So it's multiple choice. And so you'll look at the multiple choice questions and it'll say something like, you know, this is like A is a good response, but B is also a good response. And you're like, which one should I choose? And there's often like, which one is the best answer? So some of them might be factually correct or technically right, but one of them is a better answer. And so you have these kind of like distractors in there to really make sure that you know the correct answer. And then multiple response questions, I think, are far more challenging, where there's 2 or more correct responses out of 5 options, and you have to choose all of the correct ones. And there's like partial points awarded depending on how you've done that. So there's a little bit of a challenge just if you're not a good test taker. I know a lot of people really struggle with test taking. And then as it says there, unanswered questions are marked as incorrect, but there's really no penalty for guessing, which means that you're really only getting your points based on answers that you've gotten correct. And so, yeah, you definitely want to answer all of the questions and at least try for some points versus just getting a bunch of negative points for unanswered questions. So this document is very handy as far as, what's in these different domains, how much of the exam comes from each one of those different domains, and then it breaks out all of that kind of information in here. And in fact, I was going to grab this and put it in my document. So let's create, it's been a while since I've had to do Markdown. There we go. So let's paste that in there, and then I'm gonna have to format it. So like I said, today is a lot of prep and organization of notes and kind of going over some of these preliminary things before we really dig into the main study. But this is, let's see, how does that look? Did I do that right? Oh, good, that looks correct. This is one of those key things. If you're not a good studier, it took me many years to become a good studier. When I was in high school, I was not a good student. I did not get good grades. I did not care about school. And it really wasn't until I got into college and then I realized, hey, I'm learning stuff that I really think is important. Not that stuff you're taught in high school isn't important, but you have to think it's important. Then I, really realized that I needed to learn how to learn because I didn't get that in high school. And so one of the key things to being a good learner is understanding how to set up notes logically for yourself and kind of take all that information and lay it out in a way that makes sense for you and that it's organized and you're able to use it. And you're learning while you're taking notes. I know a lot of people don't realize that, but while you're putting this information down, you are actually helping yourself retain it a little better. All right, so as you can see here, this percent of examination, like what everything, these domains, like what is all going to be on the exam. There's also some sample questions so that you get an idea of the kinds of things that they're going to ask. So I'm not going to look at that just yet. But here is our list of things that are going to be on the exam. And so what I want to do is start filling in some of this information into this document and kind of, fleshing out these domains and really looking at, what goes on in here. And in one of these resources that I have in here, this free code camp, this is actually really helpful. They've got this really nice, let me zoom this out a little bit. This really nice layout of some of the different AWS certifications and things like that. So foundational, remember where it said 6 months of fundamental AWS cloud knowledge. That's this Cloud Practitioner. That's what we're talking about right now. Then you would move up into one of these associate level exams that are very specialized, and that's why there's 3 different ones. So architect, operations, or developer. Again, I'm kind of swinging between architect and developer. I have more experience as a developer, but not an AWS developer. I actually have more experience in the cloud on the architect side. So that's why it's kind of a hard choice for me. Maybe I'll go for both, but you really have to focus on one. So, and then if you wanted to move up to one of these professional level ones, then you could choose, you know, solutions architect or DevOps engineer. You can see over here on the side, there's all of these specialty ones as well. So advanced networking, big data, security, machine learning, Alexa Skill Builder. I think Alexa Skill Builder would be a great one to have. I have some experience with the Skill Builder. I can't imagine it's that terribly challenging because I find the Skill Builder to be very easy. I've heard the machine learning one of this track is like Dark Souls level hard if you don't have an already existing foundation in machine learning concepts. And so, yeah, that's probably a little challenging. So other things in here, what else? This free code camp page also goes over a lot of like role-based things. So like, what is a cloud engineer and what is a solutions architect? And so if you really are not sure and you're like, hey, I want to learn some of this cloud stuff, but how does it apply to me? On this free code camp page that I've linked in here, they have a lot of stuff just talking about these different roles and what goes into these different roles and how does it work. And then they have a prep exam or a prep video series. Let's see. It's free. It's a 4-hour course. Oh geez. On YouTube, here it is. It's like a 4-hour long video. And if you go down into here, you can see where they've broken out all of the timestamps for various things that you need to know and explained all of this. And so let's put this video into our document. Okay. As I might want to come back and look at any of these concepts that I need kind of refreshed on, that's probably helpful. All right, so let's look at how can we dig into some of these core things. I had a folder. There we go. So of course, if you don't already have an AWS account, that would be step one. You know, so going to aws.amazon.com and signing up for an account. It's not required for the exam, but if you're gonna go in there and look at things or do some kind of lab or hands-on thing or explore, then you have to have an account. So that would be like one of the first things that you would want to do. And so you can just do that. You're like, here, I'm already signed into the console. This is what it looks like when you log in, and you can see my recently visited services. You've got all of these different like build a solution things. There's a bunch of learning videos and things down here. And then the giant services menu. And it's crazy how big this has gotten, because when I first started learning this stuff, I don't know, 6 or 7 years ago, I swear this list was half this size. But it's gotten so much bigger. And there are so many things. And of course, for this particular certification, you don't have to know really anything about much of this. But there's a lot to take in. All right, so if you don't have an account, that would be important. If you do set up an account, I recommend that you set up a billing alarm. So you can do that once you have an account set up. You can go over here to the billing dashboard on the left, and here you can see, you know, I've got a lot of services and things running, so this is where my bill is at right now. And if you want to set up a billing alert, I actually have one that I need to change because I've got it set way too low, and so I get this alert all the time. Then you go to budgets and create and manage budgets. Oh wait, I thought I already had one. Because it's sending me a, maybe I just have an alert. But yeah, you can create this budget and set up various alerts. So like cost budgets or usage budgets, if that makes more sense for you. But you can set up, so we can just call this overall budget every month, reoccurring, start in May, fixed. Let's say right now, my bill is typically like somewhere between $250 and $300. So let's say I want to know, yeah, see, it's telling me last month's cost $267.56. So I want to know when I cross $250. Yeah, and here's my overall billing. So you can see there's like a nice graph. Like I don't have much in the summer, and then there's just like a ton in the fall, and we're chewing up a bunch of services right now to support online learning with this COVID thing. All right, then configure alerts. Alert threshold. Oh, see, I did this wrong. I want the budgeted amount to be higher than what I expect it to be. And then 80% of that, 240, that's fine. AWS chatbot, cool. All right, and create. See, super easy. Now I gotta figure out where that other alert's coming from. I'll probably go look at the email. It'll tell me which service is sending it. But now, and this is important, even for you when you're first getting started, I strongly recommend that you set up a budget so that as you're playing around in here, if you accidentally leave a service on or something, you aren't gonna suddenly get like a surprise bill. So whatever you're comfortable with, you know, 10, 20 bucks. Most services don't cost a lot of money, and you have to use the crap out of them to spend any significant amount of money. But it's also important to have these kinds of alerts, because if your account is compromised or something happens, like your API key gets leaked, and suddenly like Bitcoin mining spammers have your access to your account and they spin up all of these resources, and you're gonna get a $10,000 bill as a surprise. So these alerts are very important. You should set one up. I have not personally had something like that happen, but we did have a student one year that checked our API key into a public GitHub repo. And I don't know if most people are aware that there are bots that troll around and look for these kinds of things like leaked API keys. And yeah, so all of a sudden we had all of these resources being chewed up, and they got through about $30,000 worth of AWS storage and compute usage in like a 4-hour period on a Sunday afternoon. And all of a sudden, like, and it happened so quickly that like I didn't get the notifications until it was like already happening. And they were really chill about getting it all reversed and getting us secured and stuff. And that was a real learning experience for that student. So, aha. All right, so that's that. So that's the billing dashboard. You can go back to your console home and get back in here. Now let's come over to our document. In domain one of the key things that they go on about in here, let's grab, well, let's just type it. Oh, that's gonna screw this list all up. How do I want to do this? Let's do it like this. I keep typing threes. All right, and I have a bunch of notes in a OneNote notebook that I'm going to try to incorporate into here as well. But let's start with cloud concepts. So one of the cloud concepts is define the AWS cloud and its value proposition. So let's dig into that a little bit. So what is cloud computing? At least understanding cloud computing, because that can get very tricky. So I know I wrote some things about this. So if you're not familiar with how organizations leverage traditional data centers, then that's probably where we need to start. So in a traditional data center, you have, so we're talking about an organization that's not yet shifted to the cloud. Then, they have a lot of equipment. They have servers and racks and switches and network infrastructure throughout their organization to support access to this hardware. And they probably have people with jobs to manage this infrastructure at their location. And not only is all of that expensive, but let's say you are a US-based company and you want to expand into Canada or Asia. You would have to go through a process of getting a lot of initial funding to set up that initial infrastructure at your new location. So you have your home location with all of this equipment, and then you would basically need to duplicate that or some subset of that at your new expanded location. And it's going to cost a lot of money. So traditional data centers inside of an organization are expensive. They contain equipment. I had this zoomed in, so maybe you could read it. Servers, switches, hardware, etc. Plus the people to manage and maintain it. Right, you might have several different types of servers, whatever. So if you want to expand into a new area or a new geographic region, you're going to have to financially support a new set of equipment and a new data center at that location. There's very few businesses or business models that would be able to run. Like if I have a data center in my organization is in Texas and I have all this equipment, and then I decide I want to move into an Asian market, there are very, very few business models and businesses that would be able to then just open an office in Asia and call home to all of that equipment in Texas and have it work with any kind of reasonable latency. The internet speeds we have and the connection speeds we have, they just don't support that kind of situation. So, they'd have to go through a process. You would have to, set up a round of funding, or you'd have to go to your bank and you'd have to build a new data center, and building things also takes a lot of time. And on the preface of that, obtaining funding through investors or traditional banking requires time. Building things also takes a lot of time. So it not only do you have kind of like all this financial overhead, you have all this time overhead. So let's say you get this funding and you build this thing, and then you also have to hire people. To manage and maintain it. And that's also expensive. And this is what you would have to do to move into Europe, to move into the United Kingdom, to expand your business around the globe. You would have to continue this process. So, you're also adding to your own technical debt. Now, if you're not familiar with the concept of technical debt is basically where you're buying things and they're going to get old and you're going to have to afford to replace them. So not only are you buying new equipment to expand new data centers into new markets, you're also planning on replacing the equipment in your older data centers over time. So you have to plan financially to not only support future growth of your data centers, but you have to plan for upgrades and replacement of older tech as your data center ages. Boo, that sounds expensive. So, the value proposition. And this could go on and on and on. It really could. You know, like what if your business suddenly decided it wanted to get into a different tech market, and then suddenly you would need some new or different types of servers or faster connections. So when we're looking at traditional data centers, it takes a pretty large initial upfront investment. And this is some of the stuff from my original notes. So when we're looking at, I don't know why it doesn't scroll with me. It's kind of frustrating. GitHub to crap together. So when we're looking at traditional data centers, it takes an initial upfront investment, I'm gonna put large upfront investment to get it up and running. Then there is the time commitment involved for funding and building. I can't spell. As well as the commitment to people and technical debt. So now that we've said a lot of bad things about traditional data centers, you know, we didn't even really get into forecasting demand. We could stick that up here. Forecasting demand is also challenging. There's a lot of challenging demands in here. So yeah, forecasting demand is pretty difficult. And that's the process of where we need to understand, like, what are we using now, and then what are we going to be using in the future. As our business grows. And that's why this is a difficult thing for organizations to do. And even the best organizations really struggle with understanding how many users are going to latch onto a new solution or their internal business application. And so when you are a business manager, and I mean, forecasting is a big part of that business management, but like I said, even the best businesses really struggle with this. And so, you know, if you underbuild, then you have the problem where, like, you've put all this money in and you've put in all this time and everything, and it doesn't meet your business needs. And so you're having to finance additional upgrades or additions prior to when you thought that was going to have to happen. Likewise, on the flip side of that, if you have over predicted, then you've bought, you know, a $2 million data center to support $750,000 worth of business needs, and that is not sustainable. So you just start bleeding money. So, you know, organizations have to plan to either build a new data center or rent space within an existing data center to make sure that they're forecasting within kind of what that appropriate range would be for their organization. And it can be really slow to deploy new data centers and servers. Like, not everything can just be ordered overnight. This is where I should mention Amazon Prime, right? Since we're working on the AWS platform. But it's true, there's times it's gonna be difficult to, I mean, like right now, if you wanted to build a data center right now with everything coming out of China, non-existent or very slow, your business would just be dead in the water. There wouldn't be anything you could do about that. And so there's also the compliance burden. Compliance is safety and security. And so with every new data center you bring up, you have to have people who are experienced in security and data auditing to ensure that you are keeping your data safe and that it is held within the guidelines of your I've lost the term. I'm going to call it business expectations, legal requirements. So like if you are handling healthcare data or something like that, then you would definitely need to think about that. Nobody wants to be hacked. Nobody wants to be sued for being hacked. But if you're an organization owning those data centers, that entire responsibility rests on you to ensure that you're following all of the industry best practices. And so this is when we talk about the AWS Cloud's value proposition. I know it sounds like I just crapped all over traditional data centers, and I'm not saying that they are obsolete entirely or that there's never a reason you need a traditional data center. But what AWS provides is a solution to all of these things. Because they have the equipment already and have purchased all of these things, you don't have to purchase all of these things. You don't have to have the people all the time that know what they're doing. You need someone to set it up and you need someone to maintain it, either full-time or freelance. You don't need to forecast the demand. You don't need to worry about your budget and cost analysis up front because you can manage that over time. You can grow or shrink what you're doing over time. So I think that's what I've got for value proposition right now. Let's look at, well, let's talk about benefits of cloud computing. Just to contrast all of that like negative crap on data centers that I just put up there. All right, benefits of cloud computing. So cloud computing is basically, like if you're not familiar with the concept or the term, the idea that, you know, you've got this traditional model of the data center and how it works. And you don't want that. You want to do everything in the cloud. Yay, cloud. So some of the benefits that you get in this like paradigm shift to cloud computing. There's several key advantages. So let's go through, I forget how we make a numbered list in Markdown. Oh, we just put a 1 in front of it. So let's do key advantages. And let's commit, since I've typed a lot of stuff in there and I don't want to lose it. All right, how does it look? Big paragraph, key advantages, okay. Save early, save often. All right, key advantages. So the first one is that we trade capital expense for variable expense. What does that mean? Well, we talked about how traditional data centers are expensive, right? All this equipment, servers, hardware, that kind of stuff, that's capital expense. All of that money that you would have to go to the bank and ask for, go to your investors and ask for, that's capital expense. And we trade that for variable expense. So what that means is we don't have a large investment of equipment initially like we would in a data center. In the case of variability, you would get variable expenses based on usage. So, for example, if you had a server in the cloud, you're just paying for the amount of time that you use it. Someone purchased the server, they set it up, they hooked it up to the internet, they gave you access to it, and you only pay for when you're accessing or using it. So you don't have to pay for the equipment, time, installation, etc. You only pay for the time you're using or accessing the equipment. I'm going to say equipment or installation. That sounds weird. And that is a pretty significant cost savings, right? So you're running the server in the cloud, you only pay for the amount of time that you're using it. You can throw it away whenever you want. So if you are in a business, like maybe right now, when things are kind of economically unsure, and usually you use, let's say, 5 servers for capacity to support your business, but due to the coronavirus situation, everything just tanked and you don't have any users right now and you don't have any need for 5 servers, you could turn 4 of them off. And then you only pay for 1. And it saves your business an incredible amount of money over having those 5 servers sitting there that you've paid for running unused. So, big key advantage. The next one we can talk about is economies of scale. So, because we're going to talk a lot about economics for this exam, if you remember from our list up here, there's all that stuff about billing and pricing and stuff like that that has to really do with the economics of the platform. But we're going to talk a little bit about the economic stuff here. So there's 2 different areas when we talk about like massive economies of scale. So one is just the cost of building out a data center and all the equipment involved. AWS buys things at a very large scale, right? So when they go to a server manufacturer and they're like, I need a server, they don't just say I need a server, they need 100 servers, they need 1,000 servers, right? Your business might buy 5, but AWS buys hundreds. So AWS purchases equipment at a much lower cost due to the volume and quantity they are purchasing from manufacturers. This means that they can buy things much cheaper than you. So that's one of the things, like when you're building a data center and you are going to go buy servers, you're going to have to spend a lot more money than Amazon, because Amazon buys things at a very large scale. And that's basically the principle of economies of scale, right? They're going to make sure that they're getting the best price. Yep, in a way you cannot. The second way that we can talk about this is to look at it from a maintenance perspective. So Amazon can kind of determine how to manage all of these fleets of servers effectively. At scale, and that cost savings gets passed down to you. That's you. And that's basically how it works. So, where we talked about you would need to hire people to maintain all of this stuff, set it up, make sure it works, make sure it's safe and secure. They've already taken care of all of that. You don't have to worry about it. And you can stop guessing at capacity. That's I think our next point. Capacity. Your business no longer has to worry about forecasting capacity The end of sentence. You know, like we talked about, it's difficult to predict demand. And so if you don't have to do any of that, if you don't have to worry about what am I using now? What am I gonna have to use in the future? What if I suddenly gain a bunch of users? Do I have what I need? You don't have to worry about that. So systems, how do I want to put this? System and server demand in the cloud can either grow or shrink based on your needs. If your business is growing and needs more capacity, it is easy to bring up more servers or trouble with words today. I'm going to say equipment to support that. If your business is in a slump, you can scale back your usage to ensure cost savings at that critical time for your business, right? Super important. Like I talked about with this coronavirus thing going on right now. If you need to save money, then that's an important way to do it. Okay, next, what else do I have? We did economies of scale, cost savings, capacity, speed and agility. We like increased speed and agility. So what does that mean? Well, you know, when we think about our kind of hypothetical business, you might, you know, have to go acquire funds for your data center expansion. And that might mean reaching out to investors or funding partners, or, you know, going to your bank and, you know, taking out a loan or something like that. And that can be a very slow process. Obtaining funds for a traditional capital purchase, such as a data center or equipment you might need, can be very slow. Right? So that's not a very kind of agile way to do business. And so if you suddenly found yourself, you know, growing very quickly, you want to be able to support additional users or demand on your services at that time without waiting for traditional methods, right, of going and getting money, purchasing things, waiting for it to arrive, get it installed. It is pretty amazing how it's basically like click, 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 and you've added something new to your system in the cloud. So it allows your business to compete better in your market and just work faster, right? Just work better. Other things. What if you want to be able to test out, let's see, additionally, What if you want to test a new market or a hypothesis about your user base? And you want to do that quickly. Right? Traditional methods may not allow you to do that quickly. So one of the things that you can do with cloud computing that is really important, you know, for this is new ideas have minimal cost. So you can, you know, stop spending money on supporting data centers and maintaining data centers, where you have to have like staff at each of the data centers, and each of those data centers that you own have like that maintenance burden for as long as they're up and running, and we've got this compliance burden and this technical debt that's we're having to maintain, and et cetera, et cetera. We can just shift away from all that. And you can globally bring up data centers in other markets and work very quickly, and you don't have to wait 6 or 7 months to move into a new region of the world. You could just bring up a data center in Singapore if you wanted to, and you can do it in minutes as opposed to months. So that's pretty huge. One of the things that AWS talks about is and it kind of goes with this increased speed and agility, but it's elasticity. And it's this contract and expand idea about, you know, I need more so I can bring up more. Oh, I need less, let's back that off. And so the concept of elasticity means that you can acquire resources when you need them. And release them when you no longer need them. And in the cloud, you want to be able to do this automatically, because you don't want to have to pay someone to sit there and basically monitor a dashboard of like, oh my gosh, all of a sudden we're getting this influx. You know, we were on the front page of Reddit and all hell's breaking loose in our server, and we've got all these new users. What are we going to do? You want to be able to do this on demand. So in the cloud, you want to be able to expand and contract your resources on demand automatically. And AWS has several services available to do this. And that's part of that value proposition, is you don't have to pay someone to monitor a dashboard, or, you know, if your server starts ramping up or whatever. And I have this too. I've set this up. It's super easy and it's not like it's expensive, but I run a database server for my students to work on. And, you know, during the first part of the semester, it's really dormant. And so I have it at very low capacity in terms of like RAM and disk usage and things like that. As we move through the semester, it'll start to get pinged harder. When students are all logging in 2 days the night before the midterm project is due, it can really start to spike. And as it hits that capacity that I've set it's allowed to start adding in more resources. You know, it'll go from 4 gigs of RAM to 8, from 8 to 16. I might add more storage capacity if they're really adding a lot of stuff and it looks like we're going to start to get close to our disk usage. We could add another core to our processor set, make it faster, make it better as more and more people use it. And like right now, we're in the midst of finals week and a lot of students are doing their final projects. And I'm at about twice as much usage as I would see at the beginning of the semester. As you could see in my billing dashboard, you know, things kind of ramp up. So that's one of the, and I don't have to do anything. I set it up and I leave it alone. And every now and then a student says, is it kind of slow? And it's because it's kind of reaching that point where it's gonna add, and I might go in there and make some adjustments to try to mitigate some of that slowness. But that's the idea. That's the whole concept of elasticity. Acquire resources when you need them, release them when you don't. Only pay for what you use, and you can do it automatically. All right, what else do we need to talk about here? Reliability. So in a traditional data center, what happens if your data center goes down? Right? You have a backup plan, you've got a failover plan, you hope it works, no one ever tests it. Those kinds of things. So one of the advantages of the AWS kind of global infrastructure is that it's built already with that reliability in mind. You don't really have to do anything. I don't really have a lot to put here. And you can... you take advantage of it by default. There's very few AWS outages. I'm not going to say they don't happen because, you know, some of us have had enough problems with Netflix to know that there's problems with AWS in their data center sometimes. But there are ways that you can set up your applications and things so that, you know, if the East Coast data center is having problems, you can start using the Mid-Central or the West, or, you know, if you've got European customers, making sure that they're hitting the European data center for better latency. And that's, yeah, that's basically how it works. So I'm gonna save this because I've put a lot in it. Commit. All right, so this is what we have so far. In case you need that link for anyone in the chat. So here's what we wrote about value proposition, our benefits of cloud computing, all these things here. That's great. All right, what else? Anything else here? We didn't talk about security. All my notes on security are down under the shared responsibility model though, so let's just wait until we get there. Okay, so we talked about benefits of cloud computing. Aspects of AWS cloud economics, different cloud architecture design principles. So let's talk about types of cloud computing. Because it's important for what we're looking at here. Because we're gonna talk a ton about security and compliance. So, I mean, that is a benefit. It feels like a given. But we're gonna start to get into this cloud architecture design principles, and really to get into that, if you're not already familiar with cloud computing as a whole, Again, kind of approaching this from the beginner standpoint. I want to kind of dig a little bit into types of cloud computing. I'm going to like shove all this up, so I don't know, that makes it a little easier to see. So I feel like we discussed the benefits before we really talked about, we talked about what cloud computing is, but let's just talk about the different types, because you may not be aware. I know that feels weird, but a definition for kind of cloud computing as a whole. How did I format this up here? I want this to look consistent. Key advantages. So what is cloud computing? I really think it depends on who you ask what a good definition of cloud computing is, but AWS says that cloud computing is the on-demand delivery of compute power, database storage, applications, and other IT resources through a cloud services platform via the internet with a pay-as-you-go pricing. Oh, pay-as-you-go pricing. And that pricing model is critical to business success. Okay, that's their definition. Again, you go ask like Microsoft what the definition of cloud computing is, you might get something a little different based on like what they feel about Azure, but there are different models used in cloud computing. And so in order to kind of appreciate the differences, we're going to talk a little bit about those different types. So think about it like a spectrum. On one end of that spectrum, you have absolute control of what's happening, of the hardware you buy, of where it lives, all of it. But on the other end, you have this minimum maintenance, things just run, I don't have to think about it, click, 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 it happens kind of environment, right? So, I have handwritten notes in my document and I'm not really sure how to, I do not want to like clip and paste because it's just literally me drawing on the screen. Hold on, I've lost my footstool. Okay, so let's call this the all right, so on one end you have full control data center, and then we have a couple of different points along the way in this spectrum. So on this far left with our like maximum control, we have what we call infrastructure as a service. All right. That's the common abbreviation, right? Infrastructure as a service. trying to think about how to format this. Oh, I'm losing my headphones. That's not good. All right, infrastructure as a service, just some basic points. This is where my notes get kind of out of control. And this is why I want to do this document, because getting it down in this format is much more effective. So we run servers in the cloud. Virtual servers. Very similar to how we would run servers on our own data center, in that we have full access to these servers. Like, you can change the operating system that's running on them. You can completely configure them to do exactly what you want. You have to perform maintenance. You have to, you know, buy licenses and keep them up and running and everything else. Yeah, so that's infrastructure as a service. Then moving a little bit over in our spectrum here, we have software as a service. So with software as a service, and you're probably using several of these every day and you may not even realize it. Things like your email provider, chat clients that you use with other employees, you know, Slack. It's a piece of software you're able to run, and you don't have to worry about configuring servers. Right, it's just a piece of software. So in the middle between infrastructure as a service and software as a service, we have platform as a service. Actually, let's reorder. Okay. Platform as a service is really the kind of the marriage of these two ideas between infrastructure as a service and software as a service. So we're given a service that is configured for us, and sometimes we can deploy our customizations. So things like a WordPress host would be a good example of this. You can just drop in your code and you're off and running, and they configure the server and WordPress and install it for you and everything. So we have to understand kind of these different ways to use cloud computing. And like this spectrum. What does this look like? Does it look like crap? Oh, it pulled it around. Oh. Markdown formatting. Okay, let's commit this. Don't want to lose it. All right, give me just a second. I need to plug in my Bluetooth headphones, and I'll be right back. And we will continue. Okay, I have returned with working earbuds. Okay, so we've covered a lot. There's a couple more things I want to put in here. And we talked about this cloud spectrum and different types of cloud deployment models. The other thing that we could put in here What else did I have? So cloud deployment models. This would be things like public, which is just like the cloud. So if you're deploying a solution into a public cloud provider like AWS or Azure from Microsoft or Google Cloud Platform, or these are cloud resources that are available publicly for a fee, but like anyone can sign up. And set up these resources for public consumption. Versus, oh, come on now. Like a private cloud or on-prem. Stands for on-premises. So a private cloud is a cloud-like platform in a private data center. So if you wanted to be able to do something that is scalable, like with what you have with AWS, but you want to be able to do it within your own data center, then there's things like this. So and depending on your business and like the business market that you're in, sometimes this is the only way that you're allowed to do it. Specialized financial data, healthcare data, stuff like that might not be able to use a public cloud model and may have to use a more private model. And then there's the hybrid model. Of course there is. So you're leveraging the public cloud, but the public cloud applications work in tandem with a private cloud. Within their own data center. So there's a lot of solutions that you can deploy, sometimes from various companies, where you can have kind of this hybrid model, or public applications working with private applications and things like that, and understanding, especially for large organizations, that they could be using one of these types of models and what that means. That's why I wanted to get this kind of added in here. All right, I have a kind of a new section I want to start on cloud computing scenarios. And this is really kind of some thought-provoking exercises to think about scenarios and then start to run through solutions, because this is really kind of the meat of the certification portion. Let's see, formatting wise. Okay. just debating on pasting these in here instead of typing them out, but I guess I can type them out. They're not very well formatted, so that's why I've been typing out a lot of my notes. Okay, so let's start with Company A. Company A runs several production workloads within its data center. They use VMware to manage the infrastructure. In the data center. They want to not move, use AWS and integrate it in with some of their data center workload. So using the two in tandem. So the question is, then, which cloud deployment model would this company be following? Okay, and then scenario 2. Don't tap that in. All right, so we have company B. They're trying to decide whether to fund a new line of business and look at ways to monetize a new emerging technology. The new line of business will require some new infrastructure beyond what they currently have. So what benefit of cloud computing would be most relevant to company B? And then there's a third scenario with company C. They have a new CTO, Chief Technology Officer, at their insurance company. This is a medium-sized business. They are considering moving to the cloud instead of co-locating servers. Which means co-locating means they're renting space in another data center. They want to make sure they have the maximum control of their cloud servers. And they want to do that for security. So in this case, what cloud computing model would they need to leverage? I also have a couple of questions, like study questions, that I want to add in here. This was domain 1. That's what I want to name it. So our study question here is traditional data centers present challenges for organizations. There's 5 things. So it was large upfront investment, forecasting demand is difficult, it's slow to deploy to new data centers and servers. Maintenance is expensive. And you have all of the security and compliance burden. Okay, second question. AWS lists 6 key advantages of cloud computing. I'm going to break these up into individual things here. I think this will make it easier to read. All right, so 6 key advantages. You trade capital expense for variable expense. You benefit from massive economies of scale. You stop guessing capacity. Increased speed and agility. Spelling. Agility, that's such a hard word. Stop spending money maintaining data centers. Go global in minutes. Okay. Oh, I'm doing some kind of weird formatting thing that doesn't like. Oh, it's like emphasis, right? Right, so the ability to acquire resources as you need them and release resources when you no longer need them in the cloud. You want to do this automatically. Right, this was elasticity. We had the definition of cloud computing provided by AWS. I might just go copy and paste it. Our deployment models. So the model that allows for deployment onto a public cloud provider would be a public cloud. The deployment in a private data center using a cloud-like platform provided by a vendor. That would be our on-premises private cloud. Or a mixed environment of the previous two options using both a provided cloud alongside a cloud-like platform in a private data center. and that is the hybrid model. So going back to these scenarios, I guess we could put the answers in. So in the first scenario, company A, they have several production workloads. They're using VMware to manage infrastructure in the data center. They want to use AWS, integrate it with the data center. This cloud deployment model is clearly a hybrid cloud because they're wanting to use both public and private. Scenario 2, they're trying to decide whether to fund a new line of business and look at ways to monetize a new emerging technology. It will require some new infrastructure beyond what they currently have. What benefit of cloud computing would be most relevant to company B? And that would really be the pay-as-you-go. Since they don't know if this new method is going to work out, they want to do some testing and some hypothesizing. They can use the pay-as-they-go feature and not have to spend a lot of money. And then in the third scenario, they have a new CTO at their insurance company. They're wondering about moving to the cloud instead of renting space in another data center. They want to make sure they have maximum control over their cloud server. Which cloud computing model would they need to leverage? And that would be our infrastructure as a service. So I think that's it for this particular section. In this kind of initial go at it, covered quite a bit about cloud concepts. I mean, and just up front, we talked a little bit about resources and links to important things to help you study and what's going to be on the test. But really getting into how organizations leverage traditional data centers, the benefits of cloud computing, different cloud computing models, deployment models, the scenarios, some sample study questions to make sure that we understood what is written in here. So I think the next section I want to tackle is going to start with Amazon's kind of global infrastructure. We're going to start getting into this shared responsibility model. So we're done with domain 1. We're going to start getting into like regions and availability zones and things like that. But I think this was a good first start in laying down the details. Oh, this formatted this all jacked up. Let me go fix that. What has happened down here? I didn't tab over far enough, I don't think. Let's do this as bullet points instead. Let's see, did that fix it? Yes. Okay. I think I want to go through and hook up the linking. To just like make this a little easier to work with. Now I'm just doing some formatting to make this a little easier to read. And navigate as it gets bigger. Okay. There, that helps. So, I think this is where I'm going to stop for now. We did all of domain 1 today. Everything is in the document. What we talked about. We'll start next time with domain 2, discussing the security and compliance section. So this is actually a really big section. So in domain 2, we will go over the shared responsibility model, which is kind of that global infrastructure, availability zones, edge locations, some different kinds of scenarios and things in there. And then we will get into the security and compliance section, some cloud economics, security support. There's a lot of stuff in there. So hopefully, like I said, this will continue. The whole idea here is to keep this going and get this all fleshed out with my notes for those of you who are wanting to take the Cloud Practitioner Exam, and to refresh my own mind and resources so that I can start going after that higher level certification. So if you have any questions, feel free and reach out. You can hit me up in my Discord, where I am posting resources and links there as well. Happy to answer any questions and have some discussion in the Discord. Hopefully you'll keep up with me as I continue working on this and learning, and you'll be able to pursue your own cloud-based certification exam soon. So thanks for